Hello everyone. In this video, I am going to explain 8086 compare program. The statement of the program is mentioned out here. You can go through the statement. Now, for this, which instruction we need is the compare instruction. That means to write this program, we need to know the working of compare instruction. The format of compare instruction is like that: compare. We can write any two registers here. Suppose here I want to take example of compare DL comma CH. So what this instruction does, it compares the contents of DL with contents of CH. That means it does subtraction of CH from DL. That means it is DL minus CH. And after subtraction, what happens if DL is greater than CH? That means if contents of DL are greater than CH, then C will be 0, Z will be 0, and S will be 0. That means carry flag, 0 flag, and sign flag will be 0. If DL and CH contain same data, that means both numbers are equal, then C will be 0, 0 flag will be set, and sign flag will be 0. And if DL is smaller than CH, that means the number available in DL is smaller than CH, then carry flag will be 1. That means it will generate a borrow, 0 flag will be 0, and sign flag will be 1. So we are going to use this concept for writing the program. So our program statement is, if one number is at F001 and other is at F0002, that means we have two numbers that we want to compare. The one number is available in this memory location and other is at this memory location. So here 20-bit address is mentioned. So first number is here and second number is here. So we have to write an assembly language program to find largest number. That means we have to check both the numbers. We have to find out which one is greater and store that greater number. Whichever is greater, we have to store it in another memory location, that is F0003. That is, this is also 20-bit physical address. Now for writing this program, let's decide that we'll always keep bigger number in AL register. Okay. This concept of writing a program will also help us to write a bigger program. That means if string of numbers are available and if we want to search which one is the largest number, there this concept will help. Here only two numbers are available, so program is very easy. So transfer first number. First of all, I am going to tell you what is the algorithm. So what we will do, the first number is in this memory location. First we will transfer the number in this location to AL register. Then we'll compare. Now first number is in AL, we'll compare the number in AL with the second number which is in memory location. So we have to use compare instruction accordingly. So it will make subtraction, that is first number minus second number. And then based on the carry, we have to decide which number is bigger. That means if first number is greater than second number, obviously carry will not generate, borrow will not generate, and carry flag is 0. And if first number is smaller than second, then carry will generate. So what we have to do, we will check the status of carry, and based on the status of carry, we will take a decision which number is bigger. So 8 numbers, let's assume that these are 8-bit numbers. I have shown you, suppose this is a data segment, the data is available, this is the memory location, this is 20-bit physical address, and these are offsets. This is the base address of data segment, say, so this is offset. Okay, so at this offset some random number is stored. Suppose at this location, that is first number F0001, let's assume that this is 35. Not necessary that it will be always, but just for the understanding purpose, just to see whether a program is working fine or not, I have assumed two numbers, that is this location contains 30 and this location contains 35. So first number is at offset 0001. What is offset? Offset is distance of this present location, wherever data is stored, that location, distance of this location from base location. So distance is only 000, it is only one location away. So offset is 0001. Now, what is the formula for calculation of 20-bit address? We know that the formula, if data is available in data segment, the formula is data segment register into 10 plus source index register, in which DSR holds the base address and SI holds the offset. Now we know that offset is 0001. Now remember that whenever the statement of program is like this and it is mentioned that the data is available and 20-bit address is mentioned, we have to initialize memory. First step is to initialize memory, and for initialization of memory we need to know this is the formula for calculation. That means we have to enter some data in DSR. We have to enter this offset 0001 in SI, and the number should be such that when we calculate, finally whatever we get, that should be equal to F001. So when we will suppose SI is, we have already assumed this is 0001, then what we should transfer in DSR so that we get, if we use this formula, we get F0001. So for that, very simple, we have to initialize memory. For initialization memory, we have to enter this data F000 into AX register and then from AX to DSR. There is no direct instruction available for moving this F000 into DSR, that is data segment register. Hence, always first transfer into AX register and then from AX register you can transfer it to DSR. So after execution of this instruction, DSR will hold F000. Now transfer this 0001 offset into source index register by using this move instruction. So after execution of this instruction, SI will hold 0001. Now you know that in DSR there is F000 and in SI it is 0001. And now if you use this formula, you will get this particular address. So we know this address, and since we know this address, we have to decide which data, which address should be transferred in DSR and which offset should be transferred in SI. So that calculations we have to make. Now next step is, so this is shown when we use this formula, we get the required address. So this is our present address where data first number is available. Now after that, next step is, as we have decided, we will transfer the first number into AL register. So what is the instruction? Now we want to transfer the first number which is at offset 0001. Offset is stored in SI. We want to transfer it into AL. So which instruction should be used? We should use this instruction. What this instruction does, this instruction says move the contents of memory location. Why memory location? Because brackets are available. Contents of memory location. Which memory location? This memory location. Which memory location? Whose offset, that means 0001 is the offset, is stored in SI to register AL. So after execution of this instruction, what happens? AL, this 35 will get transferred in AL register. Now what is next? Now we want to compare. Now one number is in AL and other number is in memory, that is at F002. Now what we want to do? We want to compare these two numbers. So for that, what we have to do? We have to go to next memory location where second number is stored. That means for that we should increment the contents of SI. Increment the contents of SI because it is the next pointer. That means it is the next offset. So what instruction we'll use? We'll use INC SI. INC SI will increment the contents of SI register, and hence when this instruction is executed, the SI register will hold now 0002. And since SI is 002, now it is pointing out this particular memory location where second number is stored. Now what we want to do? We want to compare the number, one number which is already in AL and other number is at this particular offset. Which offset? Which is stored at SI. The offset is stored at SI. So what is the instruction? We'll compare the number in AL. So what this instruction says? Compare the number stored in AL, that means first number, with the number. Which location? Memory location, because brackets indicate second number is in memory. But which location of memory? Whose offset? This offset is stored in SI. Whose offset is stored in SI. So what this instruction does, it will compare the number in AL, that is 35, and number in this particular offset, that is number 30. So what it does, the compare instruction will subtract AL minus memory contents. So it will do AL, that is 35 minus 30. So it will perform this subtraction. And after this subtraction, it will change the flags. Now here, since 35 is bigger than 30, carry will not generate, borrow will not generate, and carry flag should remain 0. So after this instruction, we should check. What we should check? We should check carry flag if it is 0. If carry flag is 0, it indicates that the number in AL is greater because borrow is not generating. That means AL is greater than memory contents. That means we have already got the bigger number and that should be transferred to this F0003. So what instruction should be used to check the carry? We use JNC instruction. Jump if no carry. That means jump if carry flag is not set. We want to check if it is not set. We don't want to set it. If we want not set condition. So what this instruction says, jump if carry flag is not set. Where to jump? To next. Next means next is a label. We want to jump it here, and here what we will do, it indicates that carry flag is not set means carry flag is 0. That means AL holds bigger number. That means now what we, if this condition is true, we should transfer the contents, that is bigger number that is in AL, the bigger number that is in AL into this memory location, that is F0003. So we should use this instruction. That means this instruction, if this condition is true, it will directly jump from this to this instruction, that is move SI plus 1. SI plus 1 will make it 0003, AL. So this instruction says transfer the contents of AL to memory whose offset is in SI, that is SI plus 10003. This is for true condition. So what will happen? It will transfer this. If this condition is true, it will transfer AL into this particular memory location and your program should end. After this, it should halt. But what if this number is smaller? Now I'm explaining you next situation. Next situation means the entire program till this step is same. But what if number here is smaller and number here is bigger? So when we execute the same program, again move AL, SI. So first it will transfer 25 into this. Then here it is incrementing SI, so it will hold 2. Compare AL, SI, so it will make this AL holds 25 and now minus this 30. Okay. So now in this situation, if situation is opposite, it will generate carry. So here we have to check if carry is generating or not. What in the previous case, carry did not generate, so we have directly jumped to the next. But what if this condition is false? Now in this case, condition is false, carry is generating, carry will set. So if condition is false, it will execute next instruction. For false condition, it executes next instruction. We have already learned the working of JNC instruction in another video. So if this condition is false, it should execute next instruction. Now carry is generating. That means the number in AL is smaller and number in memory is bigger. The number in AL is smaller and number in memory is bigger. So what we should use, as we have assumed, we will always transfer the bigger number in AL. So we will transfer the bigger number which is in memory to AL register. What this instruction says, move AL, into bracket SI. That means transfer the contents of memory whose offset is in SI. Whose offset is in SI. That means this number to AL register, because this number is bigger now. So it will transfer it to AL. And after this, now we will transfer it to, now it is 30. And after this, we should transfer from AL to this memory location where we have to store it finally. Okay, now we will transfer this bigger number we had already transferred to AL. Now transfer from AL to next memory location, that is at F0003. So, and then it will go like this. And this is halt. So how to write entire program? For entire program, the steps are like this. So entire program should go like this. So move AX comma F00 DSR comma AX, move SI comma 0001, move AL comma SI INCSI, compare in JNC. So how the execution will happen in JNC? If this condition is true, it will skip this instruction and it will directly execute this instruction. And if this condition is false, that means if carry generates, then after this instruction first, it will execute this instruction, and after that it will execute this instruction, and after that it will execute this instruction. So if condition is true, it will skip this instruction, and if condition is false, it will execute all other instructions. So this is a very simple program for comparing two numbers that are stored in memory. I hope you understood the concept.